Today, when we talk about solar, most of us go right to the idea of photovoltaic panels, panels placed on rooftops to create electricity. But that's not the complete picture of what solar has as potential for creating alternate energy forms for us and through different mediums. So I wanted to just step us through a few of those. This is it's called a solar heliostat. The idea is that we are reflecting light from mirrors laid out in a large field towards a concentrated point. So this is a reflecting system concentrating light energy onto a single point. This, the temperature of the surface from the concentrated light is up in the thousands of degrees. It's so hot, in fact, that you can't use steam to drive a turbine as you would in a coal plant. They actually heat up salts and through their phase transition, transfer the energy down to what at the bottom here is the energy creation statement station, where that heat is probably then transferred to a fluid like steam to drive a turbine and then eventually create electricity. So this is one large scale type of plant. And these came into popularity in the 70s and 80s because of the extreme cost of crystalline photovoltaic systems to generate electricity directly. Um, and obviously the focus of where we are today is into photovoltaics, which are on the far left here. But there are other things, other ways that we can utilize direct sunshine, especially in places where energy is not readily available and plenty of sunshine is. So in the south, southwest, it's not uncommon to heat water using solar energy. So here we have a flat plate collection system where we circulate water over the metal panels that are covered with glass. They get to a high temperature and then they heat the water inside of the tank. And here the tank is placed up above on the rooftop. And this is a location where it's mounted down below. But I wanted to include this image just so you got a feeling for this idea of the circulation and then the storage of that hot water in a tank. So solar systems can involve just the heating of water for domestic use. Um, on the fringes of other ideas, I present these ideas so you know that as you see them, um, you kind of get an idea of when they came into popularity, what their value is, where we look at these ideas or these interventions today. So here we have this idea of a solar hot air system where we have replaced a section of the wall with a collector system that's heating a metal plate in here, and then air is circulating and transferring heat to the inside of the building. A large part of these original concepts lost their popularity when we made moves to insulate our buildings better and create higher performance building envelopes. But you'll still see these and you'll still see these proposed. It's very questionable about whether they are in fact um, net positive with their ability to generate energy for the building. A lot of problems happen where they actually lose energy during the nighttime because they re-radiate their energy back out. And things have to be done actively to prevent the air from recirculating through the system at nighttime. So there are complications with these, and they have a lot of upfront cost to them. And then we really get to the final about what solar energy today is mostly when we talk about it, and that's the direct conversion of sunlight to electricity. So we have a PV array, meaning photovoltaic, up on the roof. And that's not the end of the story with photovoltaic systems. One of the biggest issues is um, that energy comes at a peak time. Many times when we have peaks in air conditioning, but we have round the clock requirements for electricity. We have cloudy days, so we need to have a dependable connection to the grid as a whole so that when we have times of shade, we still have electrical energy supply. So with all that said, we generally take the power from the panels. We use it to charge backup batteries. And then we also try to invert it, make it back to AC, and push it back out into the grid, the utility grid. So the power actually is running the meter in reverse, and the electric company is actually paying to receive electrical energy from the photovoltaic array. And this has many advantages, both for the consumer and for the utility. It helps reduce peak demand from the power generating facilities by having each residence or commercial building supplying electricity to the grid system. There's many advances today in photovoltaics. They happen almost monthly. The cost of photovoltaic systems is going down, and the technologies, the flexibility of them, and I mean that both literally and figuratively, um, opens up many opportunities for us to apply them in many different ways in architectural projects that weren't commonly available to us before. So photovoltaics, as I describe them today, will look much different tomorrow, and the cost and the efficiencies, and where we apply them to our buildings and our surfaces. There's now talk of using, um, instead of putting a PV panel on the roof, actually using the photovoltaic panel itself as the roof tile. And so you reduce the cost of needing a roof system and a photovoltaic system. So that's just a brief introduction to solar energy, and we'll pick up on the next talk with wind energy.